Hello everyone, it's Miss Thomas, and today we are going to be looking at slope. Our objective is to determine the slope of a line from a graph and to calculate it from two given points. So we're going to look at some lines first and kind of discuss what slope is. Some of the lines below are quite steep, while others are not. And we're going to see multiple lines here in a moment. Below each line there is a ratio that describes how steep the line is. This ratio is called the slope. So you can see here on the first line, just as an FYI, we read our graphs from left to right just like you would read a sentence. So the slope is 1/3. On the second line, the slope is a -7/2. And on the third line, the slope is 2/2, or 1. And so I know that slope is something you're familiar with from previous classes, but it's always good to sort of take a second and figure out what these numbers mean. You can see the 1 is over here, and the 3 is here. So it's the 1, which is the vertical change, over the 3, which is the horizontal change. On the second graph, 7 again is the vertical change, and 2 is the horizontal change, and negatives tend to mess people up, but if you keep in mind that you read a graph from left to right just like you read a sentence, I'm starting here and I'm going down from left to right, so that's got to be a negative slope. And my final slope, my vertical change is 2, my horizontal change is 2, so that ends up simplifying to a slope of 1. So you need to be able to figure out the slope from a graph. You need to be able to figure out the slope from lines. It's kind of, or from 2 points. It's definitely the key feature of a line is that constant rate of change, which is the slope. The methods for finding slope. Our first method is really just counting the units of horizontal change and vertical change from one point to another on the line. So that's just like those previous graphs we were looking at. We counted how much of a vertical increase there was and how much of a horizontal increase there was. And then you want to create a ratio. So our ratio here, this is pronounced delta y over delta x. Delta is just notation that means change in. So delta y is change in y. Okay, and delta x is change in x. So most of you guys know the slope formula. And if you think about the slope formula, it's always subtraction. Subtraction finds the change in, or the difference between two values. So the change in x and the change in y is the same as the vertical change over the horizontal change. Remember, vertical goes up and down, horizontal goes left to right, which also is rise over run. So using method 1, we want to find the slope of the line. So we have this line. You can see from here to here it's already been marked as 7, and from here to here it's marked as 2. So we definitely want to make sure we know which one's vertical and which one's horizontal. This is the rise because it's going up. It's how far it's going up. Rise is always your vertical, which means this has to be your run, and run is always your horizontal. Okay, and so sometimes people forget which one's rise and which one's run, and the thing that I always tell them is you can only run on the horizontal, and you're not going to be able to run up this straight vertical line. So that's a little man running in there. It's kind of hard to tell. So the ratio, the slope, and we use the variable m for slope, is going to be rise over run, which in this case is 2 over 7. And just to double check if it's positive or negative, I am reading this starting on this end, just like I would a word. Start here and go this way, and my graph is going up, which means that it's got to have a positive slope. So for our next line, this one looks a little bit different from the previous ones. It shows sort of a fuller picture of the graph, and we've got 2 points labeled. So what I want to do, you generally, when you are finding the slope of a line, you generally only want to do it on points that cross at nice even values. You don't want to find the slope using that point right there, this point here, because they're not crossing at the grid marks. You want them to cross at the grid like 0, 1, and 1, negative 2 does. So then the other thing that we're on all of the other graphs that really helps you find slope, I typically start at my leftmost point, draw a horizontal line, and then I draw a vertical line so that I can connect those 2 points. And if you even think about it, it's almost like a triangle. It's not almost like a triangle, it is a triangle. So we can find our rise and our run. So we want to just count here. To get from left to right, we're going 1. And then to get from top to bottom, I'm going 1, 2, 3 blocks. So keep in mind, this is your run, this is your rise, because it's what's going vertically. So my rise was 3, my run was 1, but the only issue with this graph is it's negative. My rise was going down 3, so that's a negative 3. And you can double check that just thinking about reading it. If I start here and move to the left, the graph goes down over time, so that should be a negative slope. So you don't want to leave your slope as negative 3 over 1. Rewrite it as the slope equals negative 3. All right, so the second method for finding the slope is the slope formula. The slope m of the line through points x1, y1, and x2, y2 is found by m equals y2 minus y1 over x2 minus x1. So just to be clear, x1, y1 just means the first point, and x2, y2 would be the second point. Okay, so y2 minus y1 is the second y minus the first y, and then x2 minus x1 is just the second x minus the minus the first x. So a lot of you guys know this formula. You are very successful with this formula. And then I put this up, and students start to get really angry and annoyed because I've taken y1 minus y2 over x1 minus x2. And the truth is, either of these formulas is true. This formula is the exact same as this formula. The order is just reversed. So when you're doing the slope formula, it doesn't matter which x or y goes first. The only thing that matters is that your ordered pairs are vertically aligned. So you can see y2 over x2 on the first one, and then y1 over x1 on the second one. The only way that it would be wrong would be if you had something like y2 minus y1 over x1 minus y2. And it's wrong because this means that the x and y from different ordered pairs are above each other. It's incorrect. You always want to make sure that the matching coordinates are above each other. So find the slope, which I've mentioned before is the rate of change, between 5,2 and 7,3. So I'm going to do 2 examples, so I'll do them each using one of those versions of the slope formula. So let's start with the one you guys feel most comfortable with. Y2 minus Y1 over X2 minus X1. And I do recommend writing it until you have it memorized. So it also helps to label your X1s, Y1s, etc. So you know with your ordered pairs, it's always XY. And I'm going to kind of color code them as well. XY, since this is from the second set, X2, Y2, X1, Y1. Okay? So since we're using the formula where Y2 and X2 go first, my Y2 is 3. My X2 is 7, so I'll put it below. And then it's going to be minus my Y1, which is 2, and my X1, which is 5. So I should have 3 minus 2 over 7 minus 5. So when I simplify that, I want to do the subtraction first, because even though there's not a parentheses there, 1 is kind of implied. So 3 minus 2 is just a 1, and 7 minus 5 is a 2. So 1 over 2 can't be simplified. This is just my slope. All right, find the slope between -2, -2, and 0, 1. So this is an excellent example of one where I would want my x1, y1 to go first because of those negatives, and then my x2, y2 to go second. So I'm going to go ahead and use the formula where it's, the only thing you also shouldn't do is put the x's on top. Y1 minus y2 over x1 minus x2. So my x1, y1 are right here. Y goes on top, x goes on bottom. So -2 over -2 minus my x2, y2. Again, y goes on top, so my y2 is 1. My x2 is 0. So I end up with -2 minus 1, which is -3, and -2 minus 0, which is -2. So -3 over -2, this is where you definitely want to remember that a negative over a negative, or a negative times a negative, makes it a positive slope. So you can go ahead and try these two problems. Again, these are two problems. So you're finding the slope of each line. The first one is from a graph, and the second one is from a set of points.